is basically grease or oil. This dirt particle, now these hydrophobic ends are water hating. They are water hating, but oil loving. So they hate water, but they love oil and grease and this sort of stuff. So if there is a particle of grease in the water, so what will happen is that these hydrophobic ends will stick to these grease particles, and this hydrophilic ends, which love water, they will hate grease and oil. So they will want to stay away from this grease and oil. So basically the ends will come like this, where this is the hydrophobic end and this is the hydrophilic end. But there will be more particles of soap, so more can get attached to this dirt. So this will form a structure like this. That means these hydrophobic ends will come and attach to this grease particle, and these hydrophilic ends will stay away from the grease particle. And since these are positively charged, they are sodium ions, isn't it? So they will be positively charged, and this positive charge will make them repel. This positive will repel. So they will form a structure of somewhat like this. So it will form, or what you can say, like a flower like structure, and this structure is called a micelle. So there will be many such structures formed with each of the oil or grease particle. And when you, this is just oil and grease, and the micelle has formed. But when you pour water over it, that means the water will come and take away these positively charged ions, because the positively charged ions are hydrophilic, so they'll want to go with the water, and if you throw running water on top of it, then they'll flow away with the water. And since these positive hydrophilic ions are attached to this this dirt or oil through this chain, the dirt will also be washed away with the water. So basically your water will come, take away these positively charged ions, and this positively charged ions will pull away the dirt along with themselves. So that is why the dirt gets washed away. If you just take some soap and you have a dirty hand and you apply the soap on the dirty hand, then you will see that it forms a somewhat, colloidal solution. Colloidal solution is like, it will form a solution which will be a little bit opaque, little bit transparent kind of thing. That means it will not be fully transparent, it will not be fully opaque. So, and it will form, when it has formed the solution, the micelles have been formed. And then if you pour water on top of it, you'll see that the dirt goes away with the water. So this is your cleansing action of soap. Now, soaps have a very serious disadvantage, that you have this molecule, right, C17H35COO Na. This is your soap molecule. But when this soap molecule is put inside hard water. Now, what is hard water? Is water containing impurities like calcium and magnesium ions. So when this compound goes in hard water, a reaction takes place. Now, you don't need to remember this reaction. It's just that this calcium ion replaces this sodium ion and forms these calcium salts of long chain fatty acids. And these calcium salts, unlike the sodium salts, are not soluble in water, and they will precipitate as scum. So the scum is the precipitate of calcium salts, calcium or magnesium salts of long chain carboxylic acids when these ions of the hard water react with the soap. You might have seen that when you go to a beach and you play inside the sea, you go inside the sea, and then the sea contains a lot of ions, and basically it will contain magnesium and calcium ions also. So you go inside the water, you come back and you apply soap on your body. You will see that a very sticky sort of substance is formed on your skin. This sticky sort of substance is nothing but scum.